Hello and welcome back to the part 2 of our video where we explain the first material composed and delivered by engineer Abdullahi Garba Ramat. Now, in the previous one, we stopped here. We explained that the principle of conservation of linear momentum can be stated in three different ways, and each one you take is correct. You are allowed to take any one. And then we conclude by saying that closed or isolated system means a system on which no external forces act. The only forces acting in a closed system of colliding bodies are those due to the collisions. Then he says the principle of conservation of linear momentum follows from Newton's, oh, there is apostrophe here, Newton's third and second laws of motion, meaning this law is a consequence of Newton's second and third laws. And we are going to demonstrate that using Newton's second law and Newton's third law, we can derive at the equation we use for the principle of conservation of linear momentum. So, to begin with, he says, consider two bodies, A and B, of masses m sub A and m sub B. This is not MA, m sub A. The A here is a subscript. I think it's a typing error. And the B here is also a subscript. So you have two objects, object A and object B. Object A has a mass MA, object B has a mass MB, moving towards each other with velocities u sub A and u sub B, meaning u sub A is the velocity of A and the u sub B is the velocity of B. Again, this A is a subscript, B again is a subscript. Here he says that they move towards each other. Oh yeah, we have it here. Great. So we have body A, we also have body B. This object A has initial velocity u sub A and it moves in this direction, in the direction of plus x axis. And then object B has initial velocity u sub B and it moves in the opposite direction. This is before collision, before they hit on each other. Now, at collision, when they hit on each other, remember according to Newton's third law, if any two objects hit on each other, they will exert equal but opposite forces, meaning object A will exert force on object B, object B will also exert force on object A, and the two forces are equal and opposite. So object A will exert force in this direction, that is F sub A, and object B will exert force in this direction, in the opposite direction, and that is F sub B. But F sub B is equal to F sub A, the negative of F sub A. We put the negative sign because forces are vectors. If I have force in the left hand side and this in the right hand side and the force is positive, then another force in the left hand side should be considered a negative force because forces are vectors. In the same way, these velocities that we see, u sub A is in the positive x direction, so we give it a positive value. U sub B is in the negative x direction, so we give it a negative value, because vectors, when they are oppositely directed, one is considered positive and the other is considered negative. Okay, at collision, this is what happens. F A from body A and FB from body B. Now we can use Newton's second law of motion to get the magnitude of F sub A and the magnitude of F sub B. Remember, according to Newton's second law, F is equal to MA. F is equal to MA. So let's go there. Now, after collision, meaning after collision, the two objects are separated and each one moves with its individual velocity. body A moves with a new velocity v sub A in the positive direction. Body B also moves with a new velocity v sub B in the positive direction. VA and VB are both positive because they are in the direction of positive x. Okay. Um, the writer says, let the acceleration of A be A sub B because object A has acceleration, object B also has acceleration. So let the acceleration of A be A sub A, and that will be A sub B. When the two bodies collide, the force on A is equal and opposite to the force on B. We explained that. From Newton's third law, hence we can write F sub A is equal to negative F sub B. See, we are right. From Newton's second law, we know that F is equal to ma. Hence, for body A, the force exerted by body A should be mass of body A acceleration multiplied by acceleration of body A. Again, is equal to, then we put the negative sign. The force exerted by body B is mass of body B, acceleration of body B. Now, we now recall the definition of acceleration. We recall that acceleration is change in velocity divided by time, meaning final velocity minus initial velocity divided by time. We can apply this formula to A sub A and A sub B. When we apply it to A sub A, you see this will be V sub A U sub A. Okay, so it means the left hand side here will change to I will keep my M sub A, but then my A becomes this, so I will write it in bracket V sub A minus, this is a mistake, it should be A here, not B, please. The writer made a mistake here. V sub A minus U sub A divided by T is equal to, then I keep the negative sign there, M sub B, I put M sub B, open bracket, my acceleration is the acceleration of body B, so I will now say, okay, I will apply this should be V sub B minus U sub B, so divided by T, and the T is the same for all of them, where T is the contact time. When they hit on each other, let's go back here. When they hit on each other, they collide, they were in contact for some time. Now, this contact time is the time we use to measure the force. Okay, so the time is the same for all of them. Now, if you multiply both sides by t, if you want to eliminate the time, they say where t is the contact time of the two bodies during the collision and u is the initial velocity before collision, while v is the final velocity after the collision. Now, the next thing is eliminating t from equation 6.10. How, if I want to eliminate t, you see I have the t in the denominator here, I can multiply both sides by the t, and the t cancel t cancel t. Now it means on the left hand side I have ma into this, on the right hand side I have negative mb into this, so this is what I will have. You see, I will now have this, but I will let my m enter into the parentheses. Ma times this will give me mava, ma times ua, remember, will be maua. So it means I will get mava minus maua. On the left hand side, I will let my, on the right hand side, sorry, I will let my m to enter here, so mb negative outside, mb into this will be mb vb mb ub again. So on the right hand side, you see it here, mb vb minus mb ub, and the negative is here. Now if I clear bracket, this will be negative, this will be positive. If I rearrange, I will have total momentum before collision equals total momentum after collision. You see that? When I clear bracket and rearrange, I will get this. So this is why we say that this law is a consequence, is a result of the two laws of motion, the second law and the third law. We will meet in the next video.